In 36 and 37, we're going to use the completing the square technique. That involves trying to find a perfect square trinomial. Does everybody remember what those look like? Okay, an example would be x squared plus, how about 8x plus 16? The c is half of the b squared, right? So we're looking for that. It's pretty obvious in these problems that if they're telling you to complete the square, it's not going to work out as is. So a good technique in both of these, this would be a level 1 problem. This would be more of a level 2 problem because of the 4. All right? In both of these, however, I'm going to start by getting this constant over to the other side because it's probably just in the way. All right? It's not going to be a help in trying to find that perfect square trinomial. So let's try solving these at the same time. All right? So step 1, move the constant over to the other side. Then put a box for the number that will complete the square on the right. 42 equals 4x squared minus 28x. And then we have the box. Now again, that number 37 is a little tougher. So it's going to involve one other little layer to what we do next. What we do next over there, I'll put in red. It's factor out the x squared from the x, factor out the 4 from x squared and from 28x. Now, if you're sitting in this room, I hope you understand that the 28 became the 4 times 7, right? This 28 negative is this 4 times negative 7. That's called factoring out the common factor. All right, we'll come back to that one in a moment. Over here, we think, what's half of 16 squared? That's the magic number that you add in here. And in this particular technique, in this way that I'm doing it, I'm going to add it over here as well. Have you ever heard of an equation being like a balance, like a scale? And you have like stuff over here on this side of the scale and stuff over here on this side of the scale. And if you add 64 here, it weighs that side down, so you have to balance it out on the other side. Have you ever heard of that analogy in math? Yes? Good. That's what I just did by adding 64 to both sides. What do I get over here? The students say 28. Very good. On the right side, what can I turn this into? X minus 8 squared. That's just the pattern of perfect square trinomials that we tried to look at, right? We looked at a ton of them, and this is always x. This sign matches that sign, and this number should be half of your b. We are done with number 36 because all it said is to put it in this form. All right? It's in that form. X minus p squared equals q. Good? Over here, I would say this is a level 3 problem because not only did we have to factor out the 4, but our b isn't even. So when you take half of it, you get a decimal. Now, if you're not scared of decimals, this isn't that big of a deal. Half of 7 is, and 3.5 squared is bigger. 12.25. 3.5 squared should be 12.25. Double check it. So if you're thinking, big deal. So I added 12.25 on the right, so I'll add it on the left. This purple is going to disappear because it's wrong. You added 12 1/4 inside these parentheses, and who's lingering out here? So you've actually added quadruple that amount. So by adding the 49 over here, which is 4 times 12.25, if you only add 12.25, your equation is out of balance, right? So you have to remember that 4 and add 49 on this side. What do I get over here? The students say 91 equals, is this 4 still here? Sure, it's the dilation. X minus half of 7. Wait, don't forget the squared. I see that a lot. You do all this work, and you forget that little squared. I'd probably write oops and not take off, but all right.